In this video, we will be using System Modeler to model heat transfer between two bodies. We will start by changing the user mode to beginner. This leaves us with a cleaner interface with fewer options, which makes life as a beginner easier. Now, let's start by creating our model. To do this, we can choose File, New Class, or click the first item on the toolbar. Let's name the first model Heat Transfer and add a description. Now, we are going to find components for the model. The Modelica library contains models from many areas, for example mechanical, electrical, and heat transfer. Click on Modelica, Thermal, Heat Transfer, Components. Here, you will find models for modeling heat transfer systems. Dragging a heat capacitor into the workspace will include it in the model. We will set the parameter C, the heat capacity of the element, to 4000 joules per Kelvin. Notice the units and how the initial component temperature is set to 20 degrees Celsius by default. We will add a second thermal capacitor and set the parameter to the same value. Drag another capacitor from the same place as before. Find it in the recently used area, or you can duplicate the existing one by right-clicking and using the menu, or with Command plus D on macOS or Control plus D on Windows and Linux. The parameter values we have changed, in this case C, will also be duplicated. Set the start temperature to 120 degrees Celsius for the second heat capacitor. Now let's add a body radiation component. As with the heat capacitor, we can find this by navigating the class browser, but you can also search for it. Set the radiation conductance parameter to 0.75 square meters. Then select the connection tool and connect the components by clicking the connection points. Review the experiment setup by clicking the arrow next to the Simulate button on the toolbar. Change to minutes and set stop time to 15 minutes. Simulate the model by clicking the Simulation button. The simulation interface called Simulation Center opens and builds the simulation. Now we can plot heat capacitor 1.t and heat capacitor 2.t. Now you can see both the temperatures changes over time.